academic professional significance, and it gives me great joy to welcome our esteemed guests and dignitaries who have graced us with their presence today. To begin with, I take this opportunity to extend a cordial welcome to the chief guest of today's function, Dr. Chandan MC, Assistant Professor at the NITK Surathkal. Sir, your remarkable contribution to geoinformatics and urban modeling are truly inspiring, and we are privileged to have you with us today. On behalf of the GRSS student branch, we welcome you, sir. Next, I am delighted to welcome our guest of honor, Dr. Shweta HR, Assistant Professor at NITK Surathkal. Ma'am, your dedication to teaching and research is highly commendable, and we are honored to have you amidst us. On behalf of the GRSS student branch, we welcome you, ma'am. I now extend a warm welcome to the president of today's function, Dr. Srinivasa Mayadi, the principal of Srinivasa Institute of Technology. So your visionary leadership and constant encouragement continue to motivate us to strive for excellence in our every initiative we undertake. On behalf of GRSS student branch, I welcome you too, sir. I also take this moment to welcome Professor Sudarshan K, HOD of IS and CST, and also the branch counselor of IEEE student branch. On behalf of the GRSS student branch, I welcome you, sir. We are also grateful to have Dr. Praveen Shenai, the IASC coordinator, and Dr. Parvatraj KMM, faculty coordinator with us today, for gracing the occasion. Your continued support has helped us to turn ideas into impactful initiative. I welcome you, sir. Last but not the a heartfelt welcome to Ms. Yashmita Wagner, the student vice chair of IEEE, and Ms. Janma Gowda, the chair of GRSS student branch of Srinivasa Institute of Technology. We welcome you too. Last but not the least, a warm welcome to all the respected faculty members, fellow students and participants who have joined us here today. Your presence adds a lot to this event. Let us now look forward to an engaging and enriching session filled with knowledge. Have a nice day.
Thank you, Mohanesh, for the warm welcome.
I now request the president of today's event, Dr. Srinivasa Mayadi, to do a floral welcome to Dr. Shweta HR, Assistant Professor at NITK Surathkal, the guest of honor of today's function. I now request our GRSS student chair, Ms. Janma, to do a floral welcome to Dr. Chandan MC, Assistant Professor at NITK Surathkal, the chief guest of today's function. I now request our HOD of ISC and CST and IEEE student coordinator, Professor Sudarshan K, to do a floral welcome to Dr. Srinivasa Mayadi, principal of Srinivasa Institute of Technology. I now request IEEE Vice Chair, Ms. Yashmita Wagman, to do a floral welcome to Professor Sudarshan K, HOD of ISC and CST and IEEE student coordinator.
I now request Professor Sudarshan K, HOD of ISC Department and Branch Advisor of IEEE SIT, to kindly introduce our esteemed chief guest and guest of honor.
Good morning to all dignitaries on the dais and off the dais. It is my privilege to introduce our esteemed chief guest and guest of honor, whose presence truly elevates this occasion. Dr. Shweta HR is an accomplished assistant professor in Department of Water Resources and Ocean Engineering at NITK Surathkal. She holds a PhD in civil engineering from prestigious ISC Bangalore with a specialization in remote sensing applications for water resources. She completed her MTech from NITK Surathkal and BE from Malnad College of Engineering, Hassan. Her research expertise lies in optical and microwave remote sensing, hydrology, digital image processing, and machine learning for water resource management. Dr. Shweta has published several high-impact research papers in reputed international journals and conferences. She has been actively involved in projects funded by VGST and Ministry of Jal Shakti. She has guided multiple PhD and MTech and undergraduate students in remote sensing based research. She has also received Best Technical Paper Award, presented her research work globally. She is also the reviewer for international journals like IEEE, Elsewhere and Springer. Her teaching portfolio includes subjects like remote sensing, GIS, fluid mechanics, and soft computing techniques. She has also organized workshops and delivered invited talks at various academic platforms, and she is also a member of professional bodies like IEEE and IEEE Geoscience and Remote Sensing Society. Currently, she is involved in consultancy projects with ISRO, Mangalore International Airport, and Vatek Wabag Limited. Dr. Shweta continues to contribute to the field of geospatial technology, water resources and agriculture through her research, teaching and consultancy activities at NITK Surathkal. On behalf of entire team of SIT, I once again welcome you, ma'am. Next, we have with us the chief guest of today's program, Dr. Chandan MC. He is also an accomplished academician and research specializing in urban infrastructure modeling, geoinformatics and spatial decision support systems. He earned his Bachelor of Civil Engineering from NIE Mysore and his Master of Technology in Remote Sensing and GIS from NITK Surathkal. He received his PhD in 2021 from IIT Kharagpur, focusing on urban land use modeling and developing a spatial decision support for Indian cities. Dr. Chandan has over 8+ years of experience in industry, teaching and research. He is serving currently as Assistant Professor at Department of Water Resources Ocean Engineering, NITK Surathkal since December 2024. His extensive research in urbanization and geospatial data has led to the publication of numerous papers in international journals, book chapters and conferences. He is a reviewer for several prominent journals such as Scientific Reports, Indian Society of Remote Sensing, Journal of Environmental Management, International Journal of Remote Sensing, to name a few. He is an active member of professional bodies like IEEE, a senior member, GRSS, ISPRS and Indian Society of Remote Sensing. Dr. Chandan was Executive Committee member of IEEE GRS Bangalore chapter during 2021 to 23. His continued and active service was recognized and he was nominated by the state members as Secretary of IEEE GRS Bangalore chapter for the period 2024-26. Further, Dr. Chandan has received multiple awards, including the Sahyadri Ecologist Award by IISc Bangalore and various travel grants to countries such as Sri Lanka, Malaysia, China and USA from CSIR and Government of India. He has been the resource person and invited speaker at various national and international workshops and conferences. Dr. Chandan continues to mentor students and lead significant research and consultancy projects in remote sensing, urban growth development, spatial decision support system, urban flood modeling, land surface temperature and urban heat island studies. So once again, on behalf of entire team of SIT, I welcome you, sir.
Thank you, sir, for introducing our distinguished chief guest and guest of honor with such grace. To begin this inspiring journey, I request everyone to kindly rise as we invite our dignitaries on the stage for the ceremonial lighting of the lamp, symbolizing knowledge and wisdom. Kindly rise. Please be seated. Thank you, dignitaries. May this light guide our GRSS chapter to great heights.
Let us now proudly introduce the newly appointed office bearers of IEEE GRSS Student Branch Chapter, individuals who will carry forward its vision with passion and dedication. To do the honors, I now invite Ms. Aisha to introduce the office bearers.
Good morning to all. I now request our respected principal to kindly come forward and do the honors of distributing the badges to our newly appointed office bearers of the IEEE GRSS Student Branch Chapter. It is a proud moment for us to introduce the team who will be leading the chapter with commitment and enthusiasm. I kindly request all office bearers to remain on stage after receiving their badges and stand behind for our group photo session. First, I would like to introduce our chairperson, Mr. Janma A. Saragodu. Next, we have our vice chairperson 1, Mr. Safin Khan. Following him is our Vice Chairperson 2, Mr. Sumukabi. We now introduce our Secretary, Ms. Bhargavi Kulkarni. And our Joint Secretary, Ms. Sriraksha Ravi Gauraya. Moving on, we have our Treasurer, Mr. Ayush. Lastly, our webmaster, Ms. Ganavi M. We congratulate each one of you and wish you all a successful tenure ahead. May your collective efforts take the chapter to new heights.
It is our honor to welcome a highly accomplished and dedicated academician whose significant contributions and unwavering commitment to excellence continue to inspire many. We are privileged to have with us Dr. Shweta HR, Assistant Professor at NITK, Suratkal, as a guest of honor for today's event. May I now request ma'am to address the gathering.
Very good morning to the dignitaries who are present on the dais and off the dais. First of all, I would like to congratulate Srinivas Institute of Technology for starting a new student chapter because it is very important for many activities you can conduct. How many of you, first of all, I would like to ask, how many of you are already a member of Ieee-Grss? Can you please raise your hand? Yeah, that's a good number. You please make use of all the facilities which will be given by the Ieee-Grss student center. Anyway, Mr. Dr. Chandan MC will elaborate on the facilities which are available. So next, anyway, I'll reserve my energy for the workshop which is going to, which I'm going to talk about. So next, I'll just ask Dr. Chandan MC to speak a few words on IEEE student chapter. Thank you.
Thank you so much, Dr. Shweta HR, for your inspiring and thoughtful words. We truly appreciate your presence and the valuable insights you share with us today.
It is a distinct privilege to invite one of the most dynamic and inspiring academicians of our time, an individual whose vision, passion and dedication continue to inspire both students and fellow educators. We are truly honored to have with us Dr. Chandan MC, Assistant Professor at NITK Surathkal, as the chief guest for today's occasion. May I now request Sir to kindly address the gathering.
My humble pranams to the visionary and great personality Shri A. Shamarao and Shri Dr. C. A. Raghavendra Rao, founders of Srinivasan Group of Colleges. Respected dignitaries on the dais, Principal of SIT, Dr. Srinivas Mayyadi, Guest of Honor, Dr. Shweta HR, Assistant Professor in ITK Surathkal, HOD of ISC and Branch Advisor SIT, Professor Sudarshan K, and the IEEE Student Branch Chairs and IEEE GRSS Student Branch Chairs. It gives me immense pleasure to be here at SIT as a chief guest for the inaugural function of IEEE Geoscience and Remote Sensing Society Student Branch inauguration. I am honored today that I am addressing this august gathering in two different capacities or roles. Number one, as IEEE GRSS Secretary of the Bangalore chapter, and number two, as an assistant professor of Water Resource and Ocean Engineering at NITK Surathkal. I have been given 15 minutes time, so I'll try to cover whatever I want to say. My talk today covers three important aspects. One is my journey in IEEE since 2014, and the second one is about IEEE GRSS Bangalore chapter, and lastly I would like to comment, or I would like to give few suggestions for the newly formed student branch chapter at SIT. I have been a member of IEEE and GRSS since 2014, and ever since I have continued to embrace this membership because GRSS is an exceptional platform, I would say, for collaboration. When I say collaboration today, as you know, collaboration in terms of industry, collaboration in terms of academia. So without collaboration, you cannot do your internships. Without collaboration, you cannot go for your project work. Without collaboration, you cannot go for your placement. So that is where GRSS is playing a role. And also sharing information, maybe in any kind of platform, because once you become the member of such institutions or such elite groups, so we have access to many international conferences, national level conferences, hackathons, seminars and webinars and so on, where you on a regular basis meet special people who have done a significant contribution in the field of research and academia. And also to assessing the progress of the current technology, whether it is the artificial intelligence or the machine learning, or the applications what we are speaking today with respect to the remote sensing and GIS. And secondly, when we look at the IEEE GRSS Bangalore chapter, actually today I was not supposed to come here, our chair of Ieee-Grss Bangalore chapter, Dr. Shamlal, was supposed to come, but due to some emergency, he couldn't make it. So I am representing Ieee-Grss Bangalore chapter as a secretary on his behalf. It started during 2012 with the able leadership of founding chapter chair Professor B.S. Dayasagar from Indian Statistical Institute, Bangalore, with an intention to bring the like-minded IEEE members who have their passion towards the satellite remote sensing and geographical information science. If you observe the number of members over the years, it has increased almost tenfold from 2020. In the year 2020, we just had 37 members. But as I was coming to this place, I was just checking about the number of memberships. Today we have 417 members. 417. So which is around tenfold increase in the number of memberships. And why is membership so important? Because the more the membership numbers, the more is the chances of getting the global funding for running various activities in many institutions, and therefore we can secure the global funding. In turn, it helps in conducting numerous events like hackathons or faculty development program. Recently, we from NITK Surathkal, myself and Shweta madam, we did a 5 days faculty development program on satellite tracking and water resource application. And similarly, we can also conduct the student development programs. Most important for the students like you who are in the second year or third year of your engineering is exposure to field visits, right? So education is not just sitting in one room and learning some teaching, learning whatever is happening in the classroom. Rather, you have to go out and explore what is the industry and academia gap and how your CV or profile can fill that gap. If you are able to successfully manage that, then I think it should not be a problem with respect to your placement, right? So in that sense, we are talking about field trips, industrial visits and conferences, which will be helped by the IEEE, of course. And if you see, the first student branch chapter under the Ieee-Grss Bangalore chapter was started in the year 2021 at NITK Surathkal. And today I am happy to announce that the SIT student branch chapter of Ieee-Grss is the 11th SBC what we have in the entire Karnataka. And of course, there are other 2 or 3 which are already in the pipeline. They are working on it. The one example is our NITE, right? So NITE is also working on a SBC. They will start soon. Then what are the benefits of SBC, that is a student branch chapter? When we are talking about SBCs, you are basically eligible to acquire the global funding. Recently, I was working in the National Institute of Engineering for 4 years, from 2021 to 2024 as an assistant professor. There we started the student branch chapter of Ieee-Grss in the year 2023. And the moment we started, we got a seed fund of 10,000 rupees from Bangalore chapter. Then subsequently, we got 70,000 rupees to conduct a 5 days workshop. That is for 2023. Then by the end of 2023, we applied for, the proposal was sent to IEEE global funding, wherein for the year 2024, we acquired $2,000. How much is $2,000? Roughly. Now if you take it as 85,000, so it will be close to 1.7, right? 1.65 or 1.7 lakhs for 1 year. Why that fund is given to you? It is given to you to make use of that fund in any of these kind of activities. So in that direction, what we did is we spread across this 1.65 lakhs for the entire duration of 2024. We did around 8 events. Starting from field trips, we went to IISc Bangalore and we went to ISRO, URSC ISRO. Okay? And we conducted student development program on hackathons and also workshop specifically dedicated to geoprocessing and Python programming and so many other activities. In total, for the year 2024, we could able to successfully do around 8 different student activities. Still 5,000 is remaining in that account. So we are ready to do another event. So this is the kind of recognition what you get to interact with many people around the globe. And also one of the things what I would like to mention is about the distinguished lecture. So IEEE also gives you an opportunity to host distinguished lecture in your university SIT. All the financial part is taken care by IEEE. The host usually will be, the guest will be from abroad. So they will come to India and they will give, maybe it is a 3 days workshop or a 2-day workshop. The entire travel part, everything is covered by IEEE. Only thing what you should cover as a host is just the accommodation and food. So moving ahead, I'm going to the last part of my talk. To the students, please remember, honesty, dedication is very important in your tenure as a student in SIT or wherever you are. So just I was last week talking to one of the students who was doing the masters in NITK Surathkal. With respect to his output of the 2 years, whatever MTech he has done as a form of major project, it was very well articulated, it was very well mapped, the report was very good. And with so much of curiosity, I asked him, how did you run the analysis? What could be the answer? My question was simple, how did you run the analysis? So he replied, sir, the analysis was not done by me, it was done by GE, Google Earth Engine. Most of you might be knowing Google Earth or Google Maps. It is a kind of advanced version where you can run the geospatial analysis on the cloud, just by giving a simple code. So remember, today it is not a big deal to generate a code. How much time it will take to generate a code in ChatGPT? 30 seconds? 40 seconds? Maybe a couple of minutes. But what are you learning from that is more important. So in the era of AI and ML, don't just be dependent on that, because what you are doing that is just getting educated. The whole idea is not being just educated, it is to become knowledgeable. It is one level up, right? So technology will definitely change, because when I finished my PhD in 2020, there was no ChatGPT. If it was there, then my entire objective of PhD would have been very simple, not even taking 3 or 4 years. It would have been done by 6 months, right? So technologies are changing, definitely, no doubt. But when we are in the era of changing technology, we should be not just educated, we should be knowledgeable, because knowledge is going to stay with us forever. And to close my remarks, I would just like to quote a shloka, Vidya dadati vinayam, vinayadhyati patratam, patratva dhanamapnoti, dhanadharmam tatasukam. So you are in the phase where you are acquiring vidya, is knowledge. Dadati vinayam will make you humble. It should make you humble. You have to be humble, right? Then what does the humbleness give you? It will give you a character, not just the degree certificate. It is shown by your character, who you are. Patratva dhanamapnoti. It will in turn fetch you good wealth, prosperity. Dhana dharmam tatasukam. Ultimately you are reaching the happiness. So this is the pathway, it is already clearly given, right? So with this, I would like to congratulate all the office bearers and the SIT for starting the new student branch chapter, Ieee-Grss student branch chapter. I wish you a lot of success, and I also, as a secretary of Bangalore GRSS, I would also support you in acquiring the global funds. Already, if you see in the last 4 or 5 days, around 5 student branch chapters have acquired DEIAB. DEIAB stands for Diversity, Inclusivity. So that is where we have one group. Under that group, $1,000 has been allotted to 5 SBCs in Karnataka under the Ieee-Grss. So there are a lot of funding opportunities. I would request your branch counselor and your student branch chair to contact us, and a very bright future for your student branch chapter. Wish you all the very best. Thank you.
Thank you, Dr. Chandan MC, for motivating address and for gracing us with your presence today.
As a token of heartfelt appreciation and gratitude, we would now like to present mementos to our esteemed chief guest and guest of honor. I kindly request our principal, Dr. Srinivasa Mayadi, to do the honors. So please present the memento to Dr. Chandan MC, our distinguished chief guest. So please present the memento to Dr. Shweta HR, our esteemed guest of honor. Thank you, sir. We are deeply grateful to both our dignitaries for accepting our invitation and for sharing their valuable time with us today.
We now invite our esteemed principal, Dr. Srinivas Mayadi, a visionary leader and guiding force whose unwavering support and insightful leadership continue to shape the success and growth of our institution. May I now request Sir to deliver the presidential address and share his words of encouragement and wisdom on this special occasion.
Good morning to all of you. Respected chief guest of today's function, Dr. Chandan MC. The guest of honor as a resource person, Dr. Shweta HR. Professor Sudarshan, office bearers of the new students chapter GRSs, my colleagues and dear students. As we always say that we would like to give the various platforms to the students to excel in their interested field. For keeping that in the mind, we have many chapters, clubs, associations, many things are there in the society. I hope all of you know that. I don't want to brief that. To addition to that, this is the one of the things under Ieee chapter, GRSS sub-chapter was formed. So, Dr. Chandan is already briefed you why it is required and what is the importance of having that type of chapter. Thus, just technology progressing, but knowing how to use that technology is not sufficient. To know about the technology and to interpret that, you require the knowledge. How to get the knowledge? By getting the various type of activities like guest lectures or conducting workshops or development programs like that. For that, it is required to get one of the main hurdle will be getting the resource person. Knowledgeable resource person is to be very, very important. So this is the society. We can able to get the different knowledgeable people. Now today we are getting 2 people here from NITK. Both are experts in this field. So they are coming here and addressing you. You can able to get some knowledge about the remote sensing as well as geoscience. This is how you can able to acquire knowledge. The other side, for organizing this type of events, we require some funds. As Professor already briefed, under Ieee chapter, we can able to get some funds. For every event, there will be expenses. That expenses also borne by the society. So I am very happy that all you become the member of this society. Few of you have become member of the society. Surely you can able to get the knowledge on geoscience and remote sensing. You may be feeling that why it is required by us. Now, as all of you aware of that, if you restrict only one technology or one area, you can't able to progress. You should be a multi-dimensional skills. That's what is to be required. If you have that, you can able to excel. As example, professor is already given ChatGPT. Using ChatGPT, you can able to write a program. Okay. How to interpret that program? That is not anybody can able to do that. Is it engineers are required for that? Why engineers should learn coding? Example I am telling it. If you complete your engineering, you could not able to do the codings, then you may not be perfect engineers. You could able to write by yourself, and then you can able to interpret whatever the ChatGPT or any other tools will give the codes. For that you require good knowledge. One type of knowledge you can get through the classrooms, or other type of knowledges you get by participating in the different activities conducted under the different association, clubs or societies. So this is how you have to make use of this type of clubs, and you have to excel in the field. As I just say that geoscience and remote sensing is a very, very wide scope in the coming days. If you get a knowledge on that, you can excel like anything in your futures. With this, I would like to thanks Dr. Chandan and Dr. Shweta for coming here and taking initiatives by inaugurating this event and going to give us the directions for how to go ahead in the future. So we are very much thankful to both of you. Of course, I would like to congratulate the members of GRSS Club. This is the first initiative started in the college. Congratulations to all the members as well as the office bearers of the GRSS Club. It is your responsibility to taking forward and see that it becomes success in SIT. Of course, the faculty effort is to be required. Dr. Professor Sudarshan, Dr. Parvatraj and their team worked very hard to initiate and motivating you people to get this society in the colleges. I would like to congratulate who are involved, faculty members who are involved in this society. With this, I wish all of you good luck. Also, I wish great success for GRSS Club. Thank you.
Thank you, sir, for your encouraging words and for always guiding us with your wisdom.
To express our heartfelt gratitude to everyone who made today's event a success, I now invite Ms. Janma to deliver the vote of thanks.
Gratitude makes sense of our past, brings peace for today, and creates a vision for tomorrow. On behalf of the IEEE GRSS Student Branch Chapter and Srinivas Institute of Technology, I extend my heartfelt thanks to all who have contributed to making these events a grand success. First and foremost, I express our sincere gratitude to the management of Srinivas Institute of Technology for their constant encouragement, generous support, and for providing us with a platform to host such inspiring events. Next, I thank our chief guest, Dr. Chandan MC, for gracing us with his presence and sharing his valuable insights with us. On the behalf of entire IEEE GRSS team, I thank you, sir. A warm thank you to our guest of honor, Dr. Shweta HR, for joining us and inspiring the young minds of SIT with her words and presence. On behalf of the entire IEEE GRSS team, I thank you, ma'am. We are deeply grateful to our principal, Dr. Srinivasa Mayadi, for his visionary leadership and unwavering support in all our academic pursuits. On the behalf of entire IEEE GRSS team, I thank you, sir. Our sincere thanks to Professor Sudarshan K, HOD of ISC and CSD, and IEEE Student Branch Counselor for his dedicated guidance and mentorship throughout this journey. On behalf of the entire IEEE GRSS team, I thank you, sir. A special mention to Dr. Parvatraj KMM, Faculty Coordinator, and Dr. Praveen Shinoy, IIC Coordinator, for their valuable involvement and continuous support. On behalf of the entire IEEE GRSS team, I thank you both. Last but not the least, a heartfelt thank you to all our faculty members, student volunteers, and attendees for your active participation, dedication, and enthusiastic presence. On behalf of the entire IEEE GRSS team, I thank each and every one of you. Let this be the beginning of many more academic milestones. Thank you once again.
Thank you, Ms. Janma, for delivering a warm and thoughtful vote of thanks. Now I request Professor Sudarshan K, HOD, ISC and CST to escort the dignitaries of the days. Kindly rise. Now we shall begin the workshop session. Dr. Shweta HR will be discussing the topic Fundamentals of Geospatial Technologies and Applications, Past, Present and Future. Ma'am, we kindly invite you to take over and begin the session. Please be seated. Please maintain silence. The session is going to be started.
one more thing that one of my students, his name is Mr. Vasala Vasaichar. He has actually got a fund from IEEE GRS chapter, student chapter, to visit abroad, Italy, to attend workshop. Okay, so you may also make such benefit which is available from Ieee-Grss chapter, student chapter. Okay, let's move to the topic which is given to me. So before that, I would like to start from artificial intelligence for satellite image data analysis. Okay, so how many of you are aware of artificial intelligence applications? Please raise your hand. How we can make utilize of artificial intelligence? Only one? Artificial intelligence, AI. Applications of artificial intelligence. Okay, let me tell that. First thing is actually you can see here the FlyPix AI. You already know that artificial intelligence tools have revolutionized how to interpret and visualize and analyze the data which is obtained from geospatial technologies. Okay. So now there are few more applications which I have given here, which are displayed on the slide. You can see here first is actually FlyPix AI. Okay. So that AI tool, it's a platform designed to analyze the Earth's surface information obtained from geospatial technologies. So next is On-Geo Intelligence. It's a platform designed to assess the data. Assess the data, it could be obtained from the satellite. Okay, so that if you want to obtain any satellite images, you can use this On-Geo Intelligence. And next is ESODI crop monitoring. This is a platform which is specifically designed for precision agriculture. So high resolution data will be available from this. So that using that we can make use to monitor the crops and also for fertilizer management and other things. Okay. So for that actually you can use EOS, Earth Observation System Data Analytics. So that can be used to monitor the crop. And next coming to Maxar Intelligence. So if you want to get very high resolution, so I hope you know the resolution. Okay. So anyway, that information I am going to tell in other coming slides. You will get to know what I am talking about. So resolution, for example, you know the photograph, right? You know the normal camera photograph. The smallest pixel, the smallest element is actually referred as pixel. That is actually having a linear dimension of nearly 30 centimeter. So very high resolution data can also be obtained. Okay, and Dr. Chandan MC also told about GE, Google Earth Engine. So there actually you can, that's a cloud platform where you can call all the satellite images and whatever the analysis you want to do, you can do that. Okay, so these are some of the two platforms, tools available where artificial intelligence will be utilized. Okay, so with this, you got to know that without knowledge of geospatial technology, you cannot apply artificial intelligence, right? So next, what I'm going to talk about in today's talk, geospatial technologies, fundamentals and their applications. Okay, so you can see the mesmerizing pictures which are given here. So this is actually the image which are taken over Kutch of India, and here is actually the African. So this is actually the this is two images or the pictures which are showing the contrasting disaster. That is actually, first one is actually the flood and the other one is actually drought. How the drought occurs, any idea? Why drought occurs? If we don't receive sufficient rainfall, it may lead to drought condition. If we receive above normal rainfall, what happens? flood will happen, right? Yeah. So that can be seen here. You can see here there are pictures actually. In this picture you can see there is, because of sea level rise and coastal erosion, some of the areas are flooded, and here that red color and the yellow color represents how much severity of the drought. Okay. So next, coming to the third, the global picture, the image which I shown here. So that is actually how the temperature is changing over the years. So now we already know the global warming. That is actually the most problem that entire world is facing now, right now. Okay. So that is because of rise in temperature. So you can see here, this is actually the plot which is actually plotted surface temperature observation, which is plotted from 1805 to 2023. So they got to know each year there is a rise in temperature. So highest temperature was recorded in 2023. So if we 2024 also if we use, then we may get 2024 is the highest temperature recorded. Okay, so that's why it is every year there is a rise in temperature can be seen. That is actually leading to many other disaster which is happening entire world. So next is, you can see here, this is actually the satellite image which has taken over Lake Kashmir. This is actually of 30-meter resolution, okay, 30 centimeter resolution. So you can see here, now you got to know, these are all, how we got to know these images? Using geospatial technologies. So now you got a clear picture saying that geospatial technologies can give images varying, which can give information for varying from local to regional to global scale. Okay. So for many applications you can use the geospatial technologies data. So that, to show that, I have given here. So these three are the pictures which won the best photographs which are taken during global warming. So in the contest called Seize the Beauty of the Earth. Okay. So you can see here, this is actually the mangrove forest that can be seen. There is a depleting in the mangrove forest, and this is actually due to oil extraction, how the nearby areas got polluted. So that what is actually given here, and this is actually the fire. So red indicates the fire here. So this is how the spatial information, if you want to get, so we have to use geospatial technologies. So with this introduction, let's move to what is geospatial data. What is it? Any idea? How many of you are aware of geospatial data? Information along with location. Information, it could be object, it could be any phenomenon, it could be any event. So that information along with the location, if you have, that is actually referred as geospatial information. So geospatial technologies will be utilized to get those information, geospatial information. So that will be recorded in the form of attribute, okay, and also it will be having the location details along with temporal information. Altogether it is referred as geospatial data, okay. So it will be, so now geospatial data means what? It's a data which give information about any object, event, phenomenon which will be recorded in the form of attribute along with the location details and also the temporal information. That is actually geospatial data. So these geospatial data can be of two types. It will all the geospatial information which is recorded, it will be stored in two types, two categories. One is actually raster format, another one is vector format. You can see here, this is actually the real world representation, okay. So real world you have seen, no? It will be having trees, buildings, rivers, lakes, all. How these will be represented, okay. So that is actually given here. So here raster means it is actually the continuous data. So all the information will be recorded in rows and columns. You have seen, no, that the smallest element is called as grid or the pixel. Okay, you can see here the elevation. Elevation information is actually continuous information is recorded in the form of raster, and whereas land use land cover, change, that how the land has been utilized, how the land has been covered. So that is actually given in the form of raster. So you can see here, this is actually the lake. It's actually the continuous information. Okay, it will be arranged in rows and columns. So next, coming to the vector data. So you can, buildings. Now you want to represent buildings, right? So how do you represent buildings? It will be in the form of points. Okay, you can see here the points. For example, weather station data I want. So it will be in the form of points. You can see here, it will be having the information along with that location, but it is actually discrete. It is not a continuous. Okay, so it is actually in the form of points. Next, coming to the lines, roads, rivers, all these will be represented in the form of lines. Okay, you can see here, these are actually streets, all will be recorded in the form of lines. Next, coming to polygon. So all the city boundaries, political boundaries. Now you want to represent your SIT, Srinivas Institute of Technology, the boundary of the Srinivas Institute of Technology. How do you give? How do you represent? In the form of polygon. Okay, so that is what is actually. So now geospatial data can be represented in vector as well as raster data. So next we'll come to geospatial technologies. So geospatial data can be obtained from geospatial technologies. This is actually the emerging technologies. So here it is again classified as 3 categories: Earth observation, GNSS and spatial analytics. So in the Earth observation, usually Earth observation will be done using the technique called remote sensing. So remote sensing is actually without being in physical contact with any object, events or phenomenon, we want to retrieve information, we want to extract information. So that will be done using Earth observation. So this Earth observation will be done at different various altitudes, starting from ground. Okay, so ground. So if it is a ground, actually we are going to get the point, for example weather station. So that is actually without any physical contact with any weather parameter, what it happens, it actually collect information, right? So that is actually through remote sensing. So those actually located, that will give only the very less spatial information, only the point based details. So you can see here, and also best ground based geospatial technology is radar. How many of you have seen radar? Radar, ground based radar. Where do we use ground based radar? Why do we use ground based radar? Why do we use radar? You might have heard about that, right? Yes. So why do we use? Sorry? Yes, radio signals. Why do we use radio signals? Where have you seen these kind of radars will be installed? Where these kind of radars will be installed? In airport. Have you seen in airport? You might have seen the balloon kind of thing. It will be rotating. So that is actually, that will give information about rainfall. Okay, and also for tracking. Even for tracking aircrafts also, the radar will be utilized. So those are all actually ground-based geospatial technology. Okay, so this will give only up to certain extent, spatial extent, not the overall. I mean, if you want for a larger spatial extent, we cannot use the ground-based. So next we can move to little bit higher. So within 1 kilometer. So there actually what we can use in order to cover some larger portion of the Earth's surface. So we can use unmanned aerial vehicles. Okay, so unmanned aerial vehicles, there actually, So especially drones, you have seen no drones, so those will be utilized to get the information about the earth surface. Okay, so these are all come under category within 1 kilometer, which is very near to the earth surface. So next we'll move little bit higher upward. So using remote sensing technique, that is actually airborne. So there actually airbornes will be utilized. So airbornes, it can cover, compared to drones, it can cover larger spatial extent. So airborne vehicles will be utilized to capture earth information. So next we'll move to little bit higher. That is actually, there are some small satellites, even ISS, the International Space Station. Have you heard about International Space Station? How? And why you have heard about that? Why they launched that ISS? What is the purpose of ISS, International Space Station? Even that is also one of the function is actually it also observe the earth, it also monitor the earth. Okay, so for that actually it also orbits at an altitude of nearly within 400 kilometers. Okay, so next above that we get nearly 500 kilometers, we get to know the satellites. So above 500 kilometers, the satellites will be orbiting around the earth to monitor the earth surface. Okay, so next after that 30,000 kilometer, 36,000 kilometer. So there are also satellites, which are satellites, so which will give larger area that will be utilized to capture the earth information. Okay, so this is about earth observation. So next we move to GNSS, Global Navigation Satellite System. Okay, so I told you about some of the satellites which orbit within 800 kilometer will be utilized to monitor the earth's surface. Above 36,000 kilometer satellites will be utilized for the telecommunication purpose, even for the navigation purpose. So you use the Google Earth map, right? Why do you use Google Earth map? So if you want to travel from one place to another place, what do you do? If you want to travel from one place to another place, what do? You use a Google Maps, right? So there, how it is actually showing the distance, how it is actually showing the route? Using satellites. Satellites which orbit around 36,000 kilometer altitude, so those will be utilized. Okay, so that those satellites will be utilized for the navigation purpose and even for the telecommunication. There are three categories of satellites. The first category of satellites which will monitor the earth surface, which will give information about the earth surface. The second category will be utilized for telecommunication purpose. So if you want to see the live cricket match, how do you see? So using satellites again, the telecommunication satellites. And the third category is actually for navigation purpose. Okay, so the third category of satellites which will be used for the second geospatial technology, that is actually GNSS, that is Global Navigation Satellite System. So here GPS, we use for navigation purpose, we use GPS, right? So the Global Position System, that is actually developed by US, okay, in 1978, and GLONASS is actually Russian GNSS, Global Navigation Satellite System. It is actually, they started in the year 1982. And next is actually BeiDou, this is actually China's GNSS. And the fourth one is actually Galileo, is actually European Navigation System. Okay, so these four which will cover entire global. Okay, so next coming to the last two, that is actually QZSS, which is developed by Japan, and the IRNSS. Have you heard about IRNSS? Have you heard about IRNSS? No. That is actually Indian Regional Navigation Satellite System. Okay, so that cover India along with 1500 kilometers buffer. So here it is actually shown. So now we generally use GPS, right? Instead of saying GPS, what do you have to say? You have to say GNSS. Yes, correct. So you have to say GNSS, Global Navigation Satellite System. Okay. So next coming to, now we have information about Earth surface using Earth observation system. So next, GNSS will give you the location details. Okay, so to get the location details, we have to, that is actually where exactly that particular object is present, where exactly the particular event is happening. Okay, that information will be obtained from GNSS, the positioning. So next, we have Earth observation information, and also we have a location details of that particular object. So then how do we analyze, how do we visualize it? We should have some platform, right? So that platform is actually using spatial analytics. Okay, so that is actually Geographic Information System. Okay, have you heard about GIS? GIS? No? Okay, Geographic Information System is a platform. So that will be utilized for mapping, for visualizing, for analyzing the information obtained from the geospatial technologies. Okay, so these three actually comes under geospatial technologies. So with this knowledge, will one by one geospatial technology we will discuss. Starting from Earth observation. So I told you that Earth will be observed, right? Earth will be observed using satellites. Okay, we'll start from satellites using the technique called remote sensing. So how it will actually, it will sense the information, that is actually using the electromagnetic radiation. Electromagnetic radiation, which is actually the radiation which is coming from the sun. Okay, so that will be utilized. So starting from here, before discussing about the Earth observation system, so first we will discuss about electromagnetic spectrum. So you know about electromagnetic spectrum, right? You might have learnt in 11th and 12th standard. Okay, it consists of varying ranges of wavelengths, right? Starting from X-rays, which is actually having shorter wavelength, to radio signal. One student said about radio signals, no? Right? So that is actually longer wavelength. Okay, starting from shorter wavelengths to longer wavelengths. So for this observation system, we will utilize only the visible portion and thermal portion and microwave wavelengths, microwave portion of electromagnetic spectrum to observe to monitor the Earth's surface. Not only Earth's surface, even celestial bodies, even Mars, right? Even satellites have been sent to Mars also, right? Mars, even to Moon, right? So those can also be observed, also can be monitored. Okay, so next, so first, how it will be observed? So once the electromagnetic radiation which will incident on the object, so what happens? It should be reflected, or it should be observed, or it should be transmitted, right? So these, once it is actually interact with the Earth's surface, the reflected energy will be recorded by some device. It's actually called, device is called as sensor. Okay, sensor will be deployed on a satellite. So that actually will record the visible portion of electromagnetic spectrum. That is actually in the form of reflected energy. Okay, so these reflected energy will be recorded. That is actually referred as reflectance values. That is actually in the visible portion. So next will, so observed energy, what happens? After some time it has to emit, right? So it cannot hold all the absorbed energy inside the object. So that emitted energy will be recorded by the sensor. Okay, that emitted energy will be in this thermal portion. Emitted energy will be recorded. So that is actually using the thermal wavelength. So next, coming to the microwave. So here also emitted energy will be recorded. Okay, so those will be captured by these visible sensors, microwave sensors and thermal sensor which are deployed on the satellites. So already you know that all the objects emit radiation above absolute temperature. I hope that you already know about this. This is actually fundamentals of physics, that all the objects above absolute temperature emit radiation, right? Okay, so that is what is given here. So here the maximum spectral radiance which is actually emitted by the Earth's surface based on the temperature is around 9.7 micrometer. Okay, around 10 micrometer. So therefore maximum energy will be available for the thermal sensors to record. So next, whereas compared to microwave is actually very less energy is available. Okay, so less energy is available so to record by the sensors. And next, in the case of optical remote sensing, that is actually optical visible portion and near infrared and short wave infrared. So that is actually combinedly called as optical remote sensing. There actually reflected energy will be recorded by the sensors. So here all the objects or the features will be having different spectral signature. Okay, so that is actually each one of them will be having different characteristics, and based on that reflectance, energy will be reflected by them. So that will be recorded by the sensor. That is actually represent for different wavelengths and for the percentage of reflectance on y-axis and for different wavelengths. Once you get this, is a graph is called as spectral signature curve. This spectral signature curve is actually unique for features, different features. Okay, so the way we have a signature. So you all have a unique signature, right? Even objects also will be having all the features. Earth's surface feature also having their own features based on the characteristics of the features. Okay, spectral signature curve, that is actually given here. So you can see here the snow and ice is actually the spectral signature. Reflectance value is different for different wavelengths, and even for vegetation you can see this is actually the spectral signature curve, and turbid water and clear water. These will be having their own spectral signature curve. Okay, so this will enable us to distinguish, to identify which feature is present in that particular image which is taken from the geospatial technologies. Okay, so that's how we try to obtain information about Earth's surface. One is actually using visible portion. So best example I could give is actually vegetation. Okay, so vegetation, why vegetation looks green? Any idea? Why vegetation looks green? Tree, why tree looks green? Chlorophyll, because of the chlorophyll, right? Chlorophyll pigment is present. Because of how we are coming to know that is actually chlorophyll pigment is present, how much chlorophyll pigment is present? Yes, that is true. So when the electromagnetic radiation will incident on the trees, leaves, red portion will be red and blue wavelength will be, so before reaching blue actually, that's why sky looks blue, right? Because all the particles which are present in the atmosphere, that is going to scatter blue wavelength. So that's why sky looks green, blue. So next coming to vegetation, why vegetation looks, because red portion of the electromagnetic spectrum will be absorbed, and whereas the green wavelengths will be reflected. So that's why tree looks green. Okay, so similar, but beyond the visible portion we are not able to see. That we actually information will be obtained from the sensors, which are specializedly designed to record the wavelength information. Okay, so that's what is actually using those specialized sensors we are able to get the reflectance values. That reflectance, how much it will be reflected, that will be measured by that sensor. Okay, are you able to measure how much it will be reflected? How much green will be reflected, are you able to measure? We can just visualize, okay, because this much of, okay, it looks green. There are different tones of green can be seen, right? Based on the reflectance, based on the presence of how much chlorophyll content is present in the leaves. So based on that, different tones of color, green color will be visible to our eyes, right? So our eyes are only sensitive to visible portion. That's why we are able to see the different colors. That is actually red, blue, green are the three primary colors. Within that combination, we are able to sense, we are able to identify the features. But whereas, what about other wavelengths? Other wavelengths will not be able to. So therefore, other wavelengths, sensors are designed in such a way to measure the reflectance which are reflected by the features when the other wavelengths are incident on that. Okay, so that's what is actually given here. So those actually information will be obtained to identify which feature is present. So with this information, so next we'll move to the remote sensing. Remote sensing, I already told you that it's actually very effective, viable option, non-destructive method to get information about the Earth surface, to retrieve information about the Earth surface. So this is actually of two types. One is actually passive and another one is active remote sensing. In the case of passive, naturally available sun is actually the source. Okay, so there actually, so sun is actually the source. Because of sun, we are able to see. So during night time, are you able to see any objects during night time? During night time, are you able to see? No, right? You are not able. You cannot see see what feature is present. Okay. So similar way, even some of the sensors cannot see during night time. So for those sensors, sun should be available. So then only the reflected energy will be recorded. Okay. There are some sensors which are designed in such a way that it can also measure during night time as well. Even we can get nighttime information. Okay. So when the remote sensing uses sun as a source, that is actually referred as passive remote sensing. Okay. So next, coming to active remote sensing. So some of the energy, for example, microwave, I said very less amount of energy is available, right, based on the temperature available, especially if you want to get information about the Earth's surface. So when it is actually the less amount of energy is available, what happens? Will not be able to get more information, right, about that particular surface features. So therefore, what researchers thought, instead of measuring the naturally available energy, why can't we send our own energy, electromagnetic radiation? Okay, so that actually they thought of sending microwave wavelengths. Okay, so microwave wavelengths they send from the space. Okay, so then based on the interaction, some of the energies of that will be reflected back. So those will be measured. Okay, so that is actually referred as active remote sensing system, where actually artificially microwave radiation will be created, okay, generated. So that was possible because of Maxwell. Okay, he is a man behind creating artificial microwave radiation, electromagnetic radiation. Okay, so do you know about electromagnetic radiation? What is it? I am telling about electromagnetic radiation. I think it's going above your head or what? Are you able to follow? Yes. What is electromagnetic radiation? How it is actually exactly? How it travels? Any idea? Any idea? What is electromagnetic radiation? So, yes, don't discuss among yourself. You discuss with me if you have anything, any doubt. What is electromagnetic radiation? You have learnt in your in high school, I guess, electromagnetic radiation. It consists of electric field and magnetic field, correct. So how it will travel? It will propagate in such a way, perpendicular to each other. It oscillates, right? So perpendicular to each other. Okay. So what Maxwell came to know that if you induce a change in electromagnetic field, it automatically generates electric field. if we change the electric field, it automatically generates magnetic field. So that's what he actually, that was his work. Okay, so that actually led to different technologies like microwave remote sensing, where actually they can send their own microwave pulses. Okay, they generated, artificially they generated. Okay, so that is actually active remote sensing. So again, next coming to passive remote sensing, again I already told you that. So it utilizes naturally available energy, it records naturally available energy which is coming from the sun, from the earth. So optical remote sensing, it will measure the wavelengths which is coming from the visible as well as near infrared and short infrared. And next, thermal, it will measure the information. Thermal, have you, what is actually to measure the body temperature, which device do we use? Thermometer. It is similar to the same thing. So it is also measures the temperature. Okay. So I told you that all the objects above absolute temperature emit radiation. You are also emitting radiation, right? You are also emitting thermal radiation. That will also be measured by thermometer. Similar way, thermal sensor also measure the temperature, which is actually emitting from the, naturally emitting from the earth's surface. Okay, so that is actually referred as thermal remote sensing. So next is actually passive microwave sense system. Here is actually, there are two types, that is passive microwave imagers and passive microwave sounders. So passive microwave imagers, it is actually gives you the image. Sounders means, again I told you the vector data, right? So it will be in the form of discrete representation. It will be in the form of discrete values, it will be measured. Okay, so next coming to active remote sensing, again it is actually of three types. One is actually the SAR. Have you heard about SAR? SAR images. Yes. Why do we use SAR images? Why do we use SAR images? Have you seen the SAR images? Yes. Where have you seen the SAR images? Huh? Where have you seen the SAR images? Huh? Okay, so SAR images actually belongs to active microwave system. Next is actually altimeters and scatterometers. So these are all belongs to micro, because very less energy is available from the earth's surface. So therefore, they thought of sending their own pulses, artificially generated pulses to get information about the earth's surface. Okay, so here these are actually, these three are belongs to active microwave remote sensing. So now how it will be measured in the case of active remote sensing? So there are two types, I told you, three types. One is actually SAR, which is actually in the form of raster data, and scatterometers and altimeters, it will be form of vector data. Okay, so now when we send the microwave pulses, okay, so microwave pulses which will travel with the speed of light, okay, so it's going to reach the earth's surface, then it's going to interact with the earth's surface features, and then it will travel back towards the sensor. So the sensor will measure the time taken by the pulse to reach the ground and also back to the sensor. So if we know the speed of light, the speed of the pulse, if we know the time taken by that, so what we can get? Yes, correct. We can get the distance. So that distance will be measured by these altimeters. Okay. So that is actually the function. If we know the distance means, we can get to know the elevation details. Okay. Elevation of. So why elevation details are important? Why elevation details are important? Why do we need elevation? Okay, so that I will come to know why do we use elevation, okay. So that is what is actually the function of altimeters, and scatterometers will measure the scattered energy, okay. Some of the energy will be scattered when it interacts with the features. So that scattered will be measured by the scattering cross in the form of scattering cross section. Okay, so next this imaging will be having across the flight direction. It will be having one dimension, that is actually and also the perpendicular to the flight direction there is one more dimension. So it will be given in the 2 dimensions. One is actually along track and another one is across track. That's how we are able to create an image that is actually continuous image. So next is actually radar altimeters. So radar altimeters, I told you that it will measure the distance. The distance is actually here it is termed as range. Okay, here it is in the remote sensing term we call it as range. It will measure range. And next scatterometers, it will measure the scattering. How much energy will be scattered from that will be measured in the form of scattering cross section. Okay, so far we discussed about electromagnetic radiation, right? Electromagnetic radiation will be utilized to know about the Earth's surface. So similar way there are many other energies are available. Okay, so those also will be utilized to get the information about the Earth's surface. The first one is actually, here you can see the gravimeters. So it will based on the gravity. Okay, so gravity field, it's going to measure the gravity. Okay, so here you can see the gravity profile, it changes because of the presence of salt dome, right? So that will enable us, okay, which is actually present beneath the surface. Okay, so because of presence of this, it's going to change, the gravity field is going to change. So based on that we can able to say which feature is present beneath the surface. And next coming to the sonar, that is actually sound waves. Okay, so have you seen bats? Okay, so bats, what happens? So we perceive the information about the surroundings using the color. Based on the color we say this is actually the feature is present. This is actually the object is present. Based on color we say, right? Based on the color and the texture and the roughness, right? So similarly what the bats it does, it sends sound waves. Okay, it sends a sound waves and then it's going to interact, that sound waves which is sent by the bats, it's going to interact with the surroundings, and if the prey is present, it's going to, the energy will be reflected compared to other surroundings, right? So then based on that reflected energy, reflected sound waves, it's going to sense, okay, here is the prey. Okay, that similar way, even we also, the sensors also use the sound, sometimes sound waves also will be utilized to know about the surroundings. Okay, so the third one is electromagnetic wave, that is electromagnetic radiation which we discussed. Okay, so there are different force energies will be available to sense the, to know about the Earth's surface. So these are actually, I'll just skip this. Okay, so this is actually, you can see the Earth is actually covered by so many satellites now. Okay, it is covered by so many satellites. So because of that, there are debris are actually formed. So now it is actually called as space debris. Okay, so many, each satellite will be having some lifespan, right? So it can work only up to certain years. So after that what happens? It will become debris. Okay, so if there is any failure of the satellite, that is also become debris. You can see here in the low Earth orbiting satellite. So that is actually, it is actually concentrated in the low Earth orbiting satellites compared to other region. So this is how, this is actually the next. You can also the research, you can work on this, how to remove these debris. This research is going on to remove those debris. So next coming to, now you know about, you got to know about geospatial data, geospatial technologies and different energies which are available to monitor the Earth's surface. Okay, how it will be measured, how the information will be retrieved in different forms. Okay, so now what we do, how exactly the remote sensing will work. The first is actually source of energy. In the case of passive, sun is the source of energy. Whereas in the case of active remote sensing, what happens? In the case of active remote sensing, in the case of passive remote sensing, sun is the source of energy, right? In the case of active remote sensing, which is the source from where the energy will be obtained? I think you did not get passive and active remote sensing. In the case of active remote sensing, how it happens? How the information will be collected? Satellites will send the pulses, right? So that actually that will become the source of energy. Okay? So then once it is actually sent by the sensor, it's going to interact with the object of the study. So we cannot at the same time, we cannot cover entire globe. Only certain portion of the earth's surface can be covered, right? That will become object of the study. Okay? So that is actually, it's going to interact with the features which are present within that object of the study. So after interaction, what happens? It's going to travel through the atmosphere and it's going to reach the sensor. Okay? In the case of passive, sun is the source of energy. It's going to sun radiation is actually traveling through the atmosphere. It's going to interact with the object of the study. Then it will be collected by the sensor. In the case of active remote sensing, sensor itself will generate some of the electromagnetic radiation that will be sent in the form of pulses and it's going to interact, and then reflected energy will reach us the sensor. So next, after reaching the sensor, what happens? It's going to send to the data processing facility because it's going to travel through the atmosphere, right? So the energy will be attenuated because of presence of many particles which are present in the atmosphere. So there are some distortion will be present, that should be corrected. So that will be done in the data processing facility. So that will be made available for analysis and interpretation and for practical use. This is how we use. This is actually called as elements of remote sensing. Each element is very much important. Okay. So starting from the source, we should know from where we get the source and how it interacts and how it will be collected and how it will be processed and how it will be utilized or interpreted. Okay, so these are the elements of energy, remote sensing. These are all important. So next, coming to when we talk about remote sensing, so all should have information about 4 resolution. Okay, starting from spatial resolution, and the next is temporal resolution, and the radiometric resolution, and the temporal resolution, spectral resolution. So first we'll talk about spatial resolution. I already told you that when you use a camera, normal mobile photograph, okay, so mobile photograph, you know what is actually the pixel size. What will be the pixel size of your camera? Mobile photograph. So you're going to say some dimension, right? It is actually of this much linear dimension. So similar way here also you can see. So this actually, we have mapped Bangalore, Dakshin Kannada. So here 30 meter resolution, it is actually having 30 meter resolution, and it is actually 250 meter resolution, 500 meter resolution, and 1 kilometer resolution. The smallest element, the pixel, is actually having a linear dimension of 30 meter in this case. Okay, so 30 meter by 30 meter. Okay, the smallest, that 30 meter by 30 meter, it consists of either reflected energy in the form of reflectance, thermal energy in the form of temperature, the brightness temperature we call in remote sensing. Okay, and also in the case of active, we refer it as a backscattering coefficient. Okay, so each pixel will be having that value. So that value will enable us to know what is exactly present there. Okay, so in order to quantify also we can use that. So if it is actually 30 meter and 1 kilometer, when we compare 30 meter and 1 kilometer, which is actually giving more information about the Bangalore city, when you look at the pictures given here, which is actually giving more information. 30 meter or 1 kilometer? Obviously 30 meter. So 30 meter is actually referred as fine resolution, okay, compared to 1 kilometer is actually coarse resolution. Why it is actually coarse resolution? Because less energy is available in that case, whereas 30 meter more energy available, reflected energy, so therefore we use a visible portion, okay. So to map that. So this is about to get a finer resolution, okay, this is about the spatial resolution. So next coming to temporal resolution. How often the same area will be visited, okay. So here you can see this is actually MODIS and Landsat 8. It's actually, one is actually sensor and the satellite. Sensors, you can see here MODIS, it will, daily it will visit the area of interest, okay. So that's why it is actually, it is having the temporal resolution of daily, 1 day temporal resolution. Whereas here, Landsat 8, how many days? This is actually, if you consider today it has visited, after 16 days it will visit the same place, okay. So therefore it is having the temporal resolution of 16 days, after 16 days. Whereas here, MODIS, it will, today it is actually captured the information, tomorrow also it is going to capture the information. So therefore it is actually daily, whereas 16. So similar way, each satellite will be having different temporal resolution and spatial resolution. So next coming to radiometric resolution, you can see here 2 levels, 4 levels, 16 levels and 256 levels. So here all the information recorded in the form of white or black, okay, either in the form of white, extreme values, either it will be 1 or 0, binary you can say, okay. So if it is 0 means black, if it is 1 means white. So next coming to 4 levels, that is actually 2 bit, 2 to the power of 2, so 4 levels. So within that there are 4 levels of gray levels also will be, we can get in, it will be represented in 4 levels, all the information. Whereas it will be, in the case of 4 bits, 16 levels of it will, each feature will be represented 16 levels, 16 gray levels, okay. So next it is actually 256 levels. So which one is actually giving a clear information among these 4? Radiometric resolution, which is actually giving more information? 8 bit, right? So because it is actually, it is able to give same information in 256 levels, okay, levels of brightness, okay. So therefore we are going to get more information in this. So next coming to spectral resolution, this is also very much important. So I already told you the visible portion red, green, blue, okay. Even the same red portion of electromagnetic spectrum, if you split into more number of wavelengths, okay, so that is actually referred as high spectral resolution, okay. That is actually, you can see, for example here the broader one, so it is actually having all from visible portion as well as short infrared portion, it is actually all together it's going to give only one value, okay. It's the average of starting from visible portion to short wave infrared portion. So next you can come to, you can come to the next one, that is multispectral. So multispectral here, you can see here band 1, band 2 up to band 7. So here band 1 will give one reflectance value. It is actually ranging from 0.43 to 0.52, okay. So that will give one information. So next coming to 0.5 to 0.3. So that will give another information, that is actually reflectance. So first one will give information about the blue wavelength, and the second one it's give the information about the green wavelength, and the third one is actually red tonal variation, okay. So next is actually up to there are 7 bands. So that is how it is actually, how much narrower the wavelength will be, the region, spectral region narrower, we get more spectral information, okay. So that is actually we referred as, if there are more than 100 bands, 100 means 100 wavelengths will be utilized to get 100 images for the same area of the study, okay. So that's how we referred that as a hyperspectral, and next is actually superspectral. If within the 10 if there are 10 images can be obtained from the sensor, that is actually referred as multispectral sensor. And if you are able to generate more than 100 images, okay, using 100 wavelengths, that is actually referred as hyperspectral. If it is more than 1000 bands, 1000 wavelengths within that same portion, if you are able to get, that is actually referred as ultraspectral. Okay, so to demonstrate that why we have to use hyperspectral, here it is given here. You can see the spectral signature. I already told you about spectral signature, right? What is spectral signature curve, which I told you when I was explaining about optical remote sensing? Yes. What is actually spectral signature curve, which I told you when I was explaining about optical remote sensing? Reflected energy will be plotted on y-axis for different wavelengths on x-axis, right? So that is what is given here. That is actually the spectral signature curve for different features. For example, here for agriculture, for man-made turbid water and normal water. So here also, this is actually the area of the study. Okay, here you can see some of the pixels are taken out. So when we plot the reflectance values on y-axis versus the wavelengths which are available, here there are only how many bands? There are 1, 2, 3, 4. There are only 4 bands are available. 4 bands are available means only 1, 2, 3, 4. 4 reflectance values are available for that particular area of the study. So whereas this is actually using multispectral. So next, coming to hyperspectral, here how many? There are more number of bands are available. That means more reflectance values are available for the same pixels which are extracted. So therefore you can see here there is a sudden jump when you join those points. You can see the sudden variation, right? You can see the sudden jump and sudden variation. Okay, if you compare to this, there is a smooth variation. So that means when you just check this point, this particular region, here the more information is lost here. There is a sudden variation here, there is a slow variation here. You can see the reflectance value. So that's how you that's the advantage of using hyperspectral, especially when you consider crops. Okay, so are you able to distinguish when you see a image which is taken from the sensor, are you able to distinguish which crop is being grown in that particular pixel? Because all look green, same green, right? Whereas if you use hyperspectral, you are able to distinguish because of the different spectral information which is available. Because more number of bands are available, so it's able to say which particular crop is being grown. So there is a slight variation in the spectral signature curve for different crops. Okay, when you use a hyperspectral remote sensing. Okay, so these are some of the satellite sensors for different characteristics, spatial resolution, temporal resolution. When you take any satellite, you should have information about what is the spectral resolution of that, what is the radiometric resolution of that, what is the spatial resolution of that, what is the temporal resolution of that. First, you have to look for these resolutions. Okay. So based on that, you can think whether you can use for that particular application or not. For example, for urban modeling, you need very high spatial resolution. Why do you need high spatial resolution for urban modeling? Why do you need fine spatial resolution for urban modeling, for urban related studies? Because you want to get more detailed information, right? So therefore you have to use. So you have to look for the satellite which gives high spatial resolution, okay, compared to coarse. For example, for climate modeling, for climate related studies, it's fine if you use a coarser resolution, okay. Of coarser resolution in the sense you can use up to 25 kilometer, even 1 degree, that is actually even 100 kilometer resolution data is also available. That can be utilized. Yes. Okay, so this is actually the ground-based spectrometer which is available. Okay, so it is available at our NITK CRF office. So this particular instrument, ground-based spectrometer, hyperspectral spectrometer, which will give information about spectral signature curve. So that will be utilized to identify which feature is present in that particular image. That spectral signature curve is very much important. That's why I'm highlighting that. Okay. So this will give this kind of crops. I already told you that different crops will be having different spectral signature curve, right? You can see here, whereas you are not able to distinguish which crop is being grown. But whereas hyperspectral sensor can distinguish. Why? Because of this hyperspectral signature curve. Okay, so here you can see there is a slight variation in the reflected energy which is received from, which is actually recorded by the sensor, hyperspectral sensor, right? So therefore, this will enable to say which crop is being grown in that particular pixel. Okay, we'll take these spectral signature for reference and we'll try to use this information and we try to find on the image whether this particular, we try to match whether it is varying the same, it is actually following the same spectral signature curve or not. Then we try to say if it is actually matches with that, then we say it is actually this particular crop. Okay, so for that crop mapping, especially crop mapping is very much important. For that we use this spectral signature curve. Okay, so I was telling about images, right? So what is actually image? So image is actually, you can see here, each image is actually of the smallest, the pixel, it is actually the one, this is the one pixel. It is actually, the reflectance values will be measured in the form of DN values. If it is actually 256 levels means 0 to 255, right? It should give a brightness value. So based on the reflectance, for example here 0 means 0 reflectance, there is no reflectance at all. If it is actually 255, most of the energy will be reflected back. Okay, it shows that. So therefore, you can see how the image, when you zoom in the image, this is how it looks. The brightness variation of the color and each will be assigned with digital number values. That is actually, it is actually given here. So all photographs are not images, but all photographs are images, but not all images are photographs. Okay, photographs, when we refer photograph, it is actually measured only in the visible portion using photographic film. Okay, so only that is actually referred as a photograph. If you see a satellite, you have to say it as not a photograph, you have to say it as an image. Okay, so here this is actually the reflectance value. Okay, even the temperature, the measured temperature also will be sometimes, some satellite it will be measured in the form of DN value, digital number value. Okay, so then we have to convert the digital number value back to reflectance if it is required. Otherwise you can straight away you can use digital numbers. Okay, so how to visualize the image? You got to know about what is image, how it looks like. Okay, so energy which is actually incident on the sensor, which is actually recorded by the sensor, it will be in the form of voltage. Okay, it will be how much power is actually, it is recorded. So that voltage will be converted into digital number. So that's actually, that will be done by analog to digital converter. Okay, it will be converted in the form of digital. Okay, so that will be recorded there. So this is same for all the wavelengths, whatever, if you use visible portion, even microwave as well as in the thermal. Okay, that will be measured in the form of voltage, that should be converted. So how do you visualize the image? Here you can see different images. Okay, so all are actually black and white, gray level images. If you consider one band, for example red band image, if you consider, it looks like it won't be in the form of color, it will be in the form of, it will be in the in gray level image, and when you combine multiple bands, then only you are able to see the image in the form of color. Okay, so here you can see the band 1, band through band 3 up to band 7. Band 1 is actually obtained from the blue wavelength, and the green, the band 2 is actually obtained from the green wavelength, and similar way up to mid infrared. Okay, there are 7 bands are available. So how do you visualize it? How do you come to know, okay, this is how the color should be? So you can use natural color composite, that is actually 3, 2, 1. So that is actually red, green, blue. So how do for us, how the surroundings look like? Similar way, if you use blue, green, red, if you use the blue, green, red, similar way it is actually even the color is also formed in the same way. So here if you assign red color, red wavelength band, red color, and green wavelength band, green color, and blue wavelength band, blue color, so then you are going to get in this form. You can see here, these are all green color patches. This actually green color patches are actually vegetation, whereas this color patch you can see here, this is actually urban area. So here actually blue color patches, you can dark blue, that is actually the streams or the rivers. Okay, so how we look our surroundings, similar way even you can also see the images. But if you use only one image, red or any one image, you cannot get in the form of color. So you can also do, but you have to assign different color, that will be called as pseudo colors. Okay. So usually in order to if you want to highlight some of the features, for example, I want to highlight only the vegetation. Okay, so for that what I do, I'll use NIR, red and green band. So for NIR I am going to assign red color, for red color I am going to assign green color, and for green I am going to assign blue color. So that is actually, if you assign those colors, this is how the image will look like, the final image output will look like. This is actually called as false color composite image. So here you can see, when you compare with this, you can see the highlighted portion, the red color. Why do we give NIR red color? Because NIR wavelengths will be reflected more when it interacts with the vegetation. Okay, so more than 50% of the energy which is incident on the tree, on the leaves of the trees, it will be reflected back compared to green color. Okay, but we are not able to see that NIR wavelength because our eyes are not that sensitive to see that NIR wavelength. So okay, but whereas sensor can see that. Okay, so but I want to highlight that how much of area is covered by vegetation. For that actually I can use NIR band. I can assign why I am assigning red color, because compared to other colors, red color will pop up compared to other, right? So therefore I am going to assign red color to the NIR band. So that's how it is actually called as false color composite. For any vegetation related studies you can use this false color composite. This is actually referred as standard false color composite. Okay, so similar way you can also use different combination of bands to visualize the image to highlight some of the features. Okay, for example, if you want to highlight the urban then you can use the swirl bands. You can assign swirl bands red color or in that way. So then it will be highlighted compared to other color. Okay, so that's how we have to visualize the image. So next, that is actually when we take images from the optical remote sensing, that's how it look like. Looks like. Now how the temperature image will look like. This is how the temperature image will look like. You can see here, this is not measured in the form of reflectance. Here it will be measured in the form of temperature, hot or a cold pixel, you can say in that way. So here hot pixel, that is actually which are having high temperature, for that red color has been assigned compared to other color. This is actually the legend which is given there. So you can see here compared to other surroundings, here which are actually highlighted in red color, that is actually having more temperature compared to the surroundings. Similar way here, this is actually the satellite image. This is actually the normal image which is captured. So here you can see, this is actually some portion of Bombay which is taken. You can see here, this is the ocean. Ocean is actually having very less temperature compared to the land. You can see here. So other portion of land also having less temperature. So here some portion of the Bombay which is here highlighted in red color, it is actually having higher temperature. Okay, so that's how we can give colors. This is actually temperature. The thermal sensors will record the information about the earth in the form of brightness temperature. The brightness temperature will be converted into land surface temperature. So that is what is actually plotted here. Okay, next I told you that some of the sensors even can see the earth even during night time as well. Okay, even night time also it's required for us to monitor the earth. So that is what is given here. You can see this is actually during daytime, it is recorded, and this is during night time, because naturally emitting energy is actually recorded by this. So here, whereas in the case of optical remote sensing, the reflectance values you cannot get during night time. Why? Because we need sunlight. Okay, without sunlight we cannot see, sensors cannot see, the visible sensors cannot see it. That's why night time will not be available. So whereas the thermal sensor can see during night time as well. So you can see the daytime. What's the difference between these two? This is actually the urban area. So here during daytime temperature is less, whereas night time it has increased. Why these kind of studies are important? Because for urban heat island, how much energy actually, because of concrete, it's called urban area is called as concrete jungle, right? Because of that, more energy will be, more heat will be generated during night time. Okay, so that's what is actually given here. Okay, so that's why compared to the surroundings, the urban area is actually having more temperature during night time. Okay, so this is how the thermal images will look like. So with this, I'll just tell you the applications and then I'll wind up, okay? So with this background, this is actually information about how we get information about Earth's surface using different portion of electromagnetic spectrum, using different geospatial technologies. And now with this information, how we can make utilize of those images which we obtained using different sensors of different portion of electromagnetic spectrum, we can see. We can apply in agriculture, to manage the water resources, okay, and also for climate related studies and even for urban studies. So to know about how much water is, especially for water surface management. Okay, so here the surface water, how do you identify how much area of water is present? Water is important, right? How much source, how much available, water availability is more important. How do you have got the image, how do you get to know this much quantity of water is present? For water management we should know how much water is available. Then only we can actually manage that water availability, right? So for that actually here you can see, you can go back to spectral signature curve, which I explained you. That's why spectral signature curve is very much important to know, to distinguish the water body from other surface features. Okay, so you can see here, this is actually the blue color indicates, blue color is actually the spectral signature of water body, and these are all actually other spectral signature of our land, vegetation and other things. So how do you come to know the area extent, water body extent? So for that actually we use different spectral indices. Okay, how do we generate this spectral index? You can also generate your own spectral index. Okay, so but for that actually you should have information about this spectral signature curve. So using this spectral signature curve, you can also create, you can have your own spectral index developed. So here NDWI, MNDWI, there are many other spectral indices which are available. So for NDWI, green and NAR. Why green and NAR will be utilized? Because the difference between green and NAR reflectance is less compared to other spectral signature curve. Okay, so that's how we can extract, we can get information about the water body compared to other. The difference is very less, whereas when you take a difference between the NAR and green band of other features, we get more difference. So we can easily distinguish, okay, if the NDWI is actually less than this, we consider it as a water body. Above than that particular value, we consider it as other surface features. Okay, so that's how we can distinguish. Similar way, there are other spectral indices are available, so that can also be used. You can see here, it's already separated, right? Water bodies are already highlighted compared to other surface features. So that's how we make utilize of the spectral signature curve which we generated. Which instrument we use? Which ground based instrument we use to get the spectral signature curve? which instrument, ground-based instrument to be used to get the spectral signature curve? Spectroradiometer, which I showed you, that actually hyperspectral spectroradiometer, that will be utilized. So when we study that, we can get to know where exactly more reflectance is high, where is less. So then we can take a difference. So how exactly the spectral signature curve is varying for different features. So that will make utilize of that to identify which feature is present. So then we can quantify how much is actually present in that. Okay. So even for, these are all actually some of the satellites which are available. Even for temporal, if you want to know how the water body has changed over the years, right? So whether it is a decrease in water body or increase in water body. Usually most of the cases water body has decreased, right? So how do you analyze? We have to use more number of satellites. Temporal variation of satellites should be utilized, right? So then we can come to know, when you temporally we can plot the surface, water surface area extent, then we can get to know whether it is a reduction in water or increase in water body. So similar way, I already told you altimeters to know the water surface level. We know in the previous case using spectral indices, we get to know the area, spatial area extent. And from this altimeters, we get to know how much water level is present. For example, reservoir, right? Reservoir, what is the water level? So that we can get to know using altimeters. So now we know the depth of water, we know the surface area of the water. When you multiply it, what do you get? You get the volume of water, how much of water is available, right? So that's how we can get to know the water availability. So groundwater, see none of the whatever we discussed, right? So far using electromagnetic radiation, it cannot penetrate below 5 centimeter earth surface. Okay, if you want to know, for example, groundwater, want to monitor groundwater, we cannot use the electromagnetic radiation. For that, what we have to use? We have to use the gravity field, which I told you. There are different sources of energy that will be utilized, right? So here is actually one satellite, that is actually gravity satellite. Okay, so that will be utilized to know about the groundwater. Okay, here is actually the, I'll just explain this, then I'll wind up, okay? So here you can see there are two satellites, okay? So these two satellites will move like a Tom and Jerry. So these two satellites will be of 220 kilometers apart. So in the first case you can see these two are moving. The distance between those two is actually same, 220 kilometers apart. So next, as it moves towards this mass, there is a mass, that is actually there is a variation in the mass concentration. Okay, so therefore what happens? The first satellite is actually pulled by the gravity field. So therefore it's going to move little bit away from the previous second satellite. So therefore there is a distance actually is varied, right? The distance variation will actually tell us how much of mass present beneath the ground. So that information is actually given by here. So when it has actually moved when it actually over this mass concentration, when both the satellites have come over that, there is a different variation. So similar way, when it actually move away from that, there is a different distance variation. So these will actually enable us to know about how much is the mass is present. So that will give us information about, that will give us the total terrestrial water storage. So total how much of water is present within that, total amount of water is present will be given by that gravity satellite. And then when we soil moisture also we can get from the satellite, and also surface and water snow information also we can get. So when we remove that surface water and snow and soil moisture from the total water, then we are going to get the groundwater. Okay, so that's how we use the gravity satellite. Okay, but it is actually very coarse resolution. It is so for many studies it's actually used to know about how much most of the especially in Punjab area, they have extracted most of the groundwater. No, there is a groundwater depletion. So if we start extracting more groundwater, what happens? What happens? What are the consequences of depleting groundwater? So if you know that, then you will start studying all this. If you don't know, then you will not do that. Okay, so there is a even drought condition also we can get to know how the groundwater depleting, especially in India. India is actually the ranked first in extracting more groundwater. Okay, for various sector you can see most of the groundwater which is extracted will be utilized for agriculture sector. Okay, then for other things which is actually, this is actually one of the studies conducted by one researcher. So from that in the year 2010, but now actually by now actually more groundwater might have extracted. Okay, so for groundwater studies also we can use, and for to know about our other hydrological components. I think they don't know about other hydrological cycle. I just there are many cases where we use even how machine learning will be utilized. Okay, so for that actually this is actually the study which is conducted it is published in Ieee-Grss. If you want to know about this information, you can refer that particular paper which is actually quoted down. So here actually ANN, during that time 2016 I used ANN. Now we can, in order to improve the model, we can also use deep learning, other machine learning and deep learning models to get evapotranspiration. So I forgot to mention that. So from visible portion we'll get one information, right? So during cloud cover what happens? This visible portion and thermal wavelengths and visible wavelengths cannot penetrate the clouds. So therefore so we will not be able to get the information about the ground. So in that case what we have to do? We have to depend on the microwave wavelengths. Why microwave wavelengths? Because visible portion and thermal wavelengths actually shorter wavelengths compared to microwave. Microwave are the longer wavelengths. So longer wavelengths can penetrate through the clouds, whereas shorter wavelengths cannot, because there itself it will be scattered. So whatever the information given by those sensors which measure the wavelength, so that will be information on the clouds, not on the ground. Whereas microwave wavelengths can penetrate and it can give the information. So that's why we use microwave wavelengths, okay, compared to especially during cloudy sky condition. So this is actually the work where actually thermal sensors actually fail to give information about the Earth's surface temperature, where microwave has been utilized and fused with the thermal data to get land surface temperature even under cloudy sky condition as well using machine learning. Okay, so this is how the final map of that. And similar way air temperature also can be obtained. Here you can see, because of the cloudy sky condition, especially during monsoon season, will not be able to get information. So whereas these are actually obtained under cloudy sky condition. Okay, so even soil moisture also can be obtained. Even rainfall data, rainfall also can be quantified, how much rainfall is actually present. Okay, so these are all actually some of the studies conducted by my students. Okay, to quantify rainfall and which rainfall data is actually important. So even quality, water quality is also important, right? Whatever you are drinking water is actually of good quality or not. How do you come to know? So your satellite will give us information whether it is of good quality or not. So there are different water quality parameters can be retrieved from this. So to know about whether it is highly turbid or what is the pH level of that particular water, so that can also be obtained, and even how much chlorophyll content it has. If it is a more chlorophyll, is it good for drinking purpose? Is it good for aquatic life? Is it good? No or yes? No. It's no. So therefore we study that how much chlorophyll is present in that, so that we can give we can ask the authority to take preventative measure to prevent that chlorophyll content. Okay, so that's it. Even for ocean application, to know about surface wind and even ship detection, all this can be done using even chlorophyll levels. Okay, even agriculture also we can do this. Okay, so I'll just stop. crop monitoring, crop identification, even for the crop yield. These are all actually some of the studies which is conducted by my students. So here you can see, even we can get to know how much soil organic carbon is present in agriculture field using satellite images. Why it is important for us to know the how much soil organic carbon is present, how much nitrogen is present, how much potassium is present. Why it is important for us to know? Why it is important to know? Huh? Agriculture, you eat food, right? How do you get food? Huh? Yeah, so if you get a good crop yield, then only you will get food, right? Otherwise, no. So therefore what we have to do? We have to monitor, right? Monitor the quality of the food, quality of the crop which will be grown, and even how much the yield it will be. So those are all very important in agriculture studies. Okay, those are also can be done using the remote sensing. Okay, this is actually one of my PhD students have worked on that to quantify nitrogen content, soil organic carbon content, so that we can also manage fertilizer. Okay, how much fertilizer to be given to the crop based on the how much level of the quality, based on the quality of the soil. We can also suggest the farmers. Okay, so that's what is actually given. Okay, so this is actually the one study where normal photographs, using the normal mobile photographs, okay, you can also do that. For example, if you want to get the soil moisture, so if the moisture content is present, the way the soil looks is different than the dry soil, right? So that color variation can be seen. That color variation will enable you to get the information. So this is using normal digital photographs. Using mobile photographs, you can also, based on the color variation, you can see how much soil moisture is present, how much nitrogen content is present. That can also be done. Okay, even for flood and disaster management. Yeah. Okay, so that's all. So I would like to acknowledge some of the students who have worked on this. My student, Mr. Vasala Sai Charan and Bontu Sandeep Reddy, Chandana. They all worked on this, which I presented now. Okay.
Thank you, Dr. Shweta HR, for a truly enlightening session on fundamentals of geospatial technologies and applications, past, present, and future. Your insights and expertise have given us a deeper understanding of this evolving field, and we are grateful for the knowledge you have shared with us today. Now I invite Dr. Chandan MC to take the mic and share a few words with us.
Hello. So I have been given 1 hour to talk. Just kidding, 5 minutes. Okay, I am not going to be talking to you technical. So since you are a newly formed student branch chapter, most of you are curious to know how it functions. To any student branch chapter that needs to be functioned, what do you need? Student members, student volunteers, already you are there. You have a very good group of students who are already the members. Then funds, exactly. So you need money, right? So there are 3 important funding options that are available in the IEEE GRSS. So one is called as the Global Awards, which is around $2,000 to $2,500. I encourage all of you to apply for that. This is not an individual award. This is a collective award for your student branch chapter. So I request your student chairs and the office bearers. This generally the call for is done during October and November. Okay, you have to submit a proposal saying that, let us say for example, for the year 2026, what activities you are going to plan. Is it okay? So in that you can just put down the activities in the form of a field visit or a academic visit, technical visit, then student development program, hackathons, because I see that SIT you have AI/ML, information science, computer science, EC. So please go for more hackathons wherein you all can participate in that. Okay. Likewise, you please submit a proposal for $2,500. I think those who have submitted so far, whatever we have seen in the Bangalore section, all of them have got $2,000. That is one. Second one is called as DEIAB. Does anybody know what is DEIAB stand for? So it stands for diversity, equity and inclusiveness. A stands for activeness and B stands for belongingness. So in simple words, if I want to say, they just want to take all the students into consideration, irrespective of whether you are a IEEE member or not, irrespective of whether you are a information science student or a EC student, everybody can participate. And also, of course, gender, men, women, all of them. So under DEIAB, you will be getting $1,000. Okay, you just have to write a separate proposal for that, what activities you are going to do for one calendar year. Then the third one is called as industry outreach. So I hope all of you are in which semester now? Sixth semester. So next semester you are going to do your internships. The other next semester you are going to do the projects. The other next semester you are not staying in the college because you are moving out. What is your plan? So you are going for placements, right? So these three things, the internships, the project work and your placements will be with respect to what? The industries, right? So you need industry outreach. So for that also you will write a proposal. So there also you will get around $1,000. This is for one financial year. Maybe those who are in 6th semester, you might not get benefited directly to the larger extent, but your juniors are definitely going to be getting the benefit. Because this proposal timeline, if you see, most of the proposal we call during October and November, and the awards will be happening during March, April and May. By the end of May, how much funding you will get? Just now I told. Can you put all the three things together and tell me? What is the first one? Global awards. How much? $2,000. Next one? DEIAB. How much? 1,000. Next? Industry outreach. How much? 1,000. Total? 4,000. Convert to Indian rupees. Convert to Indian rupees. Roughly it is around 85 or $86 now. So you will be getting 3.6 lakhs to conduct events. 3.6 lakhs, can you conduct an event? Plenty of events, right? Is it right? So that is where the IEEE GRSS will help you to grow. Okay? So if you have any further queries, you please reach out to your student chapter chair. And remember one thing, this IEEE is not taken care by faculties. Faculty is just for the sake of advising you. How active you are, depending upon that, you will get all the benefits. Is it okay? Yes or no? There is no energy. Is it okay? Will you apply for funding? Do you want the benefits of funding? Okay, that's good. Thank you. Thank you so much.
Thank you, sir. Before we conclude, I would like to extend a heartfelt thanks to our chief guest, Dr. Chandan MC and Dr. Shweta HR, for gracing the occasion and sharing their valuable insights with us. We are truly grateful for their presence and contribution. A special thanks to all the faculty members and students for their active participation and constant support throughout the workshop. Your enthusiasm and involvement played a vital role in making this event a great success. Thank you all.